In this module, you will learn to determine the truth value of implication or conditional statements. We know that a compound statement is the combination of two or more simple statements using and, or, and so on. Let's consider another type of compound statement. If you work hard, then you will pass the examination. This statement involves two statements. You work hard, you will pass the examination. Now, the compound statement can be expressed as if P, then Q. In this case, if statement P is true, then statement Q will be true. Such compound statements are called implications or conditional statements. It is formed using the connecting words if-then. The implication can also be written as P implies Q. This is represented using the arrow-like symbol as shown. The symbol stands for implies. Note that a compound statement, if P then Q, is always true, except in the case when P is true and Q is false, because a true statement cannot imply a false statement. That means, if you do not work hard, then you cannot say whether you will fail or pass the examination. In other words, P not happening has no effect on whether Q happens or not. Let's consider another statement. If 3 is a factor of 9, then it is also a factor of 18. The component statements that are involved in it are 3 is a factor of 9, 3 is a factor of 18. Statement P implies statement Q, or 3 is a factor of 9 implies that 3 is also a factor of 18. The implication or conditional statement P implies Q can also be expressed as shown. Let's look at the converse, inverse, and contrapositive of an implication. Consider an implication P implies Q. The converse of the given implication is Q implies P. The inverse of the given implication is given by negation P implies negation Q. The contrapositive of the given implication is negation Q implies negation P. Let's write the converse, inverse, and contrapositive of the implication. If two sides of a triangle are equal, then it is an isosceles triangle. The component statements of the compound statement are: two sides of a triangle are equal, the triangle is isosceles. The implication of the statements is P implies Q. The implication or conditional is: if two sides of a triangle are equal, then it is an isosceles triangle. The converse of the implication is: if a triangle is isosceles, then two of its sides are equal. The inverse of the implication is: if two sides of a triangle are not equal, then it is not an isosceles triangle. The contrapositive of the implication is: if the triangle is not isosceles, then two of its sides are not equal. Let's look at another implication. If the sides of a triangle are equal, then its angles are also equal. The converse of this implication is: if the angles of a triangle are equal, then its sides are also equal. Here both the statements are true. Such statements can also be expressed as: the sides of a triangle are equal if and only if its angles are equal. Such compound statements are called a bi-implication or biconditional. A compound statement involving statements P and Q which is in the form of P if and only if Q, is called a by-implication or biconditional. A by-implication is represented by a double imply symbol. The by-implication P if and only if Q can also be expressed as shown. Remember here that if P and Q have the same truth values, either true or false, then the by-implication is true. If either P or Q is false, then the by-implication is false.